Welcome to this video on acid basicity. What does that term mean and how can we classify acids using that terminology? Acid basicity is also known by another term, which is proticity. I tend to prefer the term proticity because acids are proton donors, and I think it links more clearly to the meaning, which is the number of H+ ions per molecule which are replaced in an acid-base reaction. It's the basicity. Easiest way to do it is to actually look at some examples. So let's start with hydrochloric acid, HCl. Now when that reacts, let's say for example it reacts with sodium hydroxide, it's going to become NaCl. So in other words, we've had here one hydrogen atom that's been replaced with a sodium. And so that type of acid is known as monobasic. Or it might also be known as monoprotic, mono meaning one. That would example be something like HCl. Okay, a diprotic or dibasic is something like sulfuric acid, H2SO4. We've got here two hydrogens that are going to be replaced. Say for example might become Na2SO4. Both hydrogens are being replaced. Triprotic acid will be next on the list, or tribasic. That's something like phosphoric acid. We've got H3PO4. You react that with something like sodium hydroxide, all three of those hydrogens will be replaced, and so you've got a triprotic acid. Now we've got a couple more to classify. Nitric acid, that's HNO3, that would be monoprotic. And then we come to ethanoic acid, which is an interesting one, so I'll just draw its structure out here. So this would be, I'll do a displayed formula just to show you. So this is the structure of ethanoic acid. Now what's the proticity here? Now this is where we need to be really careful. It's the number of H+ ions per molecule which are replaced in an acid-base reaction. Now in principle any hydrogen is acidic. So we could say here, well, its proticity is going to be 4. It's going to be tetraprotic. But actually that's not the case, because when this reacts, the only hydrogen that's actually replaced is this one here. So if this reacts with, say, sodium hydroxide, we just get a negative ion on there, and the Na+ will come here. And so this one's actually another example of monoprotic. So ethanoic acid is a monoprotic, and all carboxylic acids are monoprotic. Or every carboxylic acid functional group, let's say, is monoprotic. So when we're trying to find something which is tetraprotic, we need to be a little bit more careful, and it might be interesting for you to try and just pause the video now and see, can I think of any tetrabasic or tetraprotic acids? Well, you've had a little think. Here's an example that I've got, which is, imagine we've got a carbon atom here and 4 carboxylic acid groups coming off. That would be an example of a tetraprotic acid. There's doubtless going to be other examples. I'm not sure this molecule actually exists. You might have to stick a CH2 group in as well just to stop the clash between these groups. But something which has got 4 carboxylic acids, each one of these hydrogens can be removed in an acid-base reaction. So a little bit of question time for you now. What is the proticity of each of these molecules? Pause the video and see if you can assign them. Well, you've had a go. We have a look at the functional groups. This is a carboxylic acid, so that hydrogen's going to go. This is an alcohol. Alcohols generally aren't acidic, so these two are not going to be removed. Got another carboxylic acid on the end here, so this is 2. This is a diprotic or dibasic acid. This one here, boric acid, well, you might not be too sure. Not all OHs do get removed, as we've seen with alcohols. So alcohols are not acidic, but in this case, these all are. This is boric acid, so this one can go, this one can go, and this one can go. So this is actually tribasic. It's another example. And then this one here, by the same token, we've got 3 carboxylic acid groups here. So they're all going to be deprotonated, but the alcohol won't. So this is going to be a tribasic acid as well. This is actually citric acid in this case. This is called tartaric acid, and this is boric acid. And that's acid, basicity and proticity.